So good day class. Our topic is about the types of series convergence tests, and one of those tests is this one, okay, geometric series test. So in this test, okay, it applies to a series of the form the summation of a times r raised to n, where a is the first term of the series, r is the common ratio, and the n represents the nth term in the series. So here is the following condition. So if the absolute r is less than 1, then the series converges, and it has a sum or partial sum which is equal to a over 1 minus r. Just simply use the formula a over 1 minus r to compute for its partial sum or the limit of the series. So again, a is the first term of the series and the r is the common ratio. Next, so another condition is that if r is less than, or I mean if the absolute value of r is greater than or equal to 1, then the series diverges. So those are the conditions in order to identify if the series converges or diverges. Just focus on the value of the absolute value of r. Okay, you may use this test when the series clearly follows a geometric progression. Again, if you have given this series, and as you can see, it is geometrically patterned. Okay, it has a common ratio. Okay, so you can use this geometric series test. Okay, so let's have an example. Okay, so in our first example, we have this following series. We have 12 plus 4 plus 4 over 3 plus 4 over 9 plus 4 over 37 plus so on and so forth. Okay, so the question is, does this series converges or diverges? Okay, so let's identify. Okay, let's analyze rather the series. Okay. So as you can see, we have our first term 12 and its next term is 4. So what happened here is that it is reduced by 1/3, right? Next, so this time we have this term 4, right? And its next term is 4 over 3, and still it is reduced by 1/3. So so if we continue, to analyze the pattern, all of the terms are reduced by 1/3. So basically, so this means that it is a geometric series, and it has a common ratio which is equal to 1/3. Okay, so at this point we can now identify if the series is a convergent or divergent by looking at the value of the common ratio. So again, if the r or the absolute value of r is less than 1, then the series is convergent. Okay, otherwise, if the value of the absolute value of r is less than, or wait, let me correct. So if the value of the absolute value of r is less than 1, okay, it is convergent. And if the r is greater than or equal to 1, therefore it is divergent. Okay, divergent. So, and since we have value of r which is equal to 1/3, and this 1/3 is less than 1, therefore the answer is convergent. Okay, the following series, this one is convergent. Okay, so I hope I let myself clear. I made myself clear, no? Next, maybe, I don't know. So another example. Okay, so let's analyze this. Okay, so given that we have this series with the general formula, 9 raised to negative quantity n minus 2 times 4 raised to n plus 1. Okay, so let's identify if this series is a convergent or divergent. It should be divergent, no? Divergent or convergent. Okay, so so we can use the pattern, okay, the summation of a times r raised to n minus 1, no? Okay, let's use this pattern, no? Evaluating from n equals to 1 up to positive infinity. Okay, so let's align or reconstruct this given general formula to this pattern. Okay, so let me rewrite this first. So we have 9 raised to negative n minus 2. Don't forget the quantity. So we have 4 times 4 raised to n plus 1. Okay, equals 4 raised to n plus 1 over 9 raised to n plus 2. Okay, so we simply reciprocate this term. This term now, we reciprocate this term. Okay, next, so so ideally we want to have an exponent which is r raised to n minus 1, right? So let me write 4 raised to n minus 1 over 9 raised to n minus 1. Okay, next, so to retain the original value, which is this one, okay, to retain the original value, so we must find a constant, any value that if we multiply it here, this to this one, the answer will be this one. Okay, again, let's find a value, any value that if we multiply it here in our 4 raised to negative n minus 1, no? The answer will be 4 raised to n plus 1, as well as if we need to find another value here in the denominator, and if we multiply it to 9 raised to n minus 1, the answer will be 9 raised to n plus 2. Okay, so the value, the possible value that we can use is 4 raised to 2, okay, and 9 raised to okay, 9 raised to 2. Wait, it should be n minus 2. Okay, n minus 2. Then the exponent here should be 9 raised to minus 1. Okay, so let's check. So if we multiply 4 raised to n minus 1 to this term 4 raised to 2, the answer will be 4 raised to n plus 1, right? Negative 1 minus negative 1 plus 2 is simply, we have 1, positive 1. Next, if we multiply 9 raised to n minus 1 by this term, 9 raised to negative 1, so we simply get the answer 9 raised to n minus 2, right? Next, okay, next is, so let me write here, so we have 4 raised to n okay, so we just simplified this. So we have 4 squared times 9. Okay, so what happened here, so basically it is we're simplifying this one. Okay, we're simplifying this one. Okay, so we have 4 squared times 9 times 4 over 9 quantity raised to n minus 1. Okay, okay, next further simplify. So we have 144 here. Okay, times 4 over 9 raised to n minus 1. So we already achieved the pattern. No? It is similar. This answer, okay, this answer is similar to this pattern. Okay, right? It is similar. So we can now analyze, okay, or get the value for the R, or the common ratio. So further analyze. So the R here, so we have A, let us we have A equals 144 and R equals 4 over 9. Okay, and by since we already know the condition, okay, we know that R, the value of our R is less than 1. Therefore, this series, okay, this series, okay, this following series is a convergent. Okay, it is a convergent series.